In section 11.7, we are going to be multiplying, dividing, and simplifying square roots. These are three things we've already done, and we're going to practice doing them together to simplify products and quotients of more complicated expressions. So an example of the sort of expression that we're going to be simplifying, I have right here, 3 radical 6 over radical 20, and we're going to want to get that into the simplest form possible. Now, in order for you to know exactly what we have to do, you probably want to know what will an expression in simplest form look like. Sometimes people throw around that term simplest form and it's a little bit vague. For us, simplest radical form is going to have 3 important characteristics. The first one is going to be that the number under the radical has no perfect square factors. And of course, when I mean no perfect square factors, I mean nothing other than 1. So we don't want any 4s or 9s or 16s or 25s in there. And additionally, we only want to have one radical in the final answer. So that example up there that has the radical 6 and the radical 20 in there, that idea. Now, second characteristic. In our final answers, we're not going to want to have any fractions left under the radical, only whole numbers. The third thing we have to be careful of is that if our final answer is a fraction, and it's going to turn out to be the case that it usually will be, we don't want to have any radicals in the denominators of those fractions. And now that we know these 3 important characteristics of a radical expression in simplest form, we also just need to think briefly about the tools that we're going to use to simplify. And the tools that we're going to use to simplify are those 2 properties of square roots that we've been talking about since the very beginning of chapter 11, the multiplication property and the division property. These are going to turn out to be very, very useful to us in simplifying all of our radical expressions. So it's going to be important for us to remember that if we have something like the square root of a times b, we can break that up into the square root of a times the square root of b, and also that if we have the square root of a times the square root of b, we can go backwards and make that the square root of a times b so we can multiply. And it will also be important to remember that if we have a fraction under a radical, we can break that up and make it be the square root of the top over the square root of the bottom. Or if we have a radical divided by a radical, we can combine that into one fraction underneath the radical. Both of these properties are going to be very useful to us in doing these problems. We are going to start by doing an example that violates our first rule about things that we are not supposed to have in simplified expressions, and that's more than one radical or a radical that's not simplified. So the way to attack a problem like this is going to be by multiplying together what we might call like terms. Because we want to simplify, we want to try to combine as much as we can. So we can multiply together the numbers, and we can also, we know, multiply together the radicals. So when I multiply together my numbers, that's 3 times 4. I'm going to get 3 times 4, or 12. And I know that I'm multiplying those numbers times the radicals multiplied together. So that's the square root of 2 times the square root of 18. And the square root of 2 times the square root of 18 is going to be the square root of 36. Now, we know that to finish up this answer, the great thing about this is the square is 12 times 36 is really just a 6. So this turns into just 12 times 6. And 12 times 6 is just 72. And that will be our final answer. So you can see that by multiplying together the numbers and multiplying together the radicals, we found something, this square root of 36, that we could simplify, making our answer much nicer. In our next example, you'll see that we have a different problem. Well, we have the same problem. We have 2 radicals, and we also have an additional problem. Both of these radicals contain fractions, something that we don't want, because again, we want one radical that's simplified inside, and we don't want any fractions under the radical. So our approach will be similar to the last problem. We're going to try multiplying these radicals together to create something that can be simplified. So I'm going to multiply these radicals together on the inside. So I'm going to put everything under one big radical. And I'm actually going to take the shortcut of not doing the actual multiplication, just writing what it would look like. So I do 3 times 14 on the top and 7 times 27 on the bottom. And the reason I'm doing that is this. Because then we've already learned that before we take the square root, we can simplify inside the radical. So what I mean is this. We've got this 14 and this 7. So I'm going to cancel them out. I'm going to make the 14 a 2 and the 7 a 1. I'm going to do the same thing with the 3 and the 27. I'm going to make the 3 a 1 and the 27 a 9. So what I'm left with is the square root of 2 over 9. Now you know we have a problem here. We have our fraction underneath the radical. But we can get rid of that using division. So, of course, what I mean is that I'm going to write this as the square root of 2 divided by the square root of 9. And I bet you can already see why that's a great option, because then we can say that for our final answer, we can have the square root of 2 on the top, and on the bottom, the square root of 9 just becomes a 3. So for our final answer, we can say square root of 2 over 3. No fraction under the radical, simplified radicals, there's only one, and there are no fractions in the denominator. Now, we're going to take a look at an example where we, again, have fractions inside the radicals, but it's not quite the same thing. In this example, we don't start with a fraction inside a radical. However, we do start with a radical inside the denominator of a fraction, which we don't want. So, a way to get rid of this problem would be to combine these two radicals into a fraction underneath a radical. So here we're basically doing what we did in the last example, but with division instead of multiplication. So I'm going to take this 15 and this 20 and divide the radicals, making a fraction underneath. So we kind of got rid of one problem, having the radical in the denominator, created another one. However, this is a problem we can solve, because now we can try simplifying inside the radical. So this is exactly the same thing I was doing before. I'm going to divide by 5 and get 3, divide by 5 and get 4, which leaves me with 3 times the square root of 3 over 4. Now, we can change this back into division, and hopefully we'll be able to simplify. So when I change to division, we're going to have 3, and we can think of that as sort of being like 3 over 1, so that's going to be on the top of our fraction, times the square root of 3, and on the bottom of the fraction, we'll have the square root of 4. Now, we can simplify this to get a final answer, because we can say that 3 times the square root of 3 is good on top, 1 radical can't be simplified, and instead of 4 on the bottom, we can just write a 2. And so we will have our final answer of 3 radical 3 over 2. So the difference between example 3 and example 2 was that back here in example 2, we started by multiplying the two radicals together, whereas here in example 3, we divided the two radicals. Both times we were then able to simplify inside the radical, change to division, and simplify, getting the same result. Now in this example, you notice that we were able to also get rid of this radical in the denominator, which is something else that's not going to be allowed for us by changing this to division. There are some problems where this does not work. Example 4 is an example of a problem where this doesn't work, because there's no radical in the top of this fraction to combine with a 7, and maybe something good will happen simplification-wise. When there's no other way to get rid of a radical in the denominator, maybe it's not the square of 9, so we can't make it a 3, it's just sitting there by itself. The most go-to way to remove a radical from the denominator, sorry, misspoke there, is using a process called rationalizing the denominator. So when I say rationalize the denominator, that means we're removing radicals from the denominator of a fraction. This is really, really, really important. So here's what we're going to do. This is really tricky and sort of algebra magic. We are going to take this original expression and we're going to multiply it by something that's going to get rid of that radical 7 in the denominator. And it turns out that what you need to multiply it by is a form of 1. And this form of 1 is created in a very special way. And the form of 1 we're going to use is going to be whatever that radical in the denominator is over itself. So here's what I mean. I mean the radical in the denominator is 7. So we're going to multiply by radical 7 over radical 7. So that's just one thing over itself. And the reason this is legal is because if we're doing an original and then we're just multiplying it by 1, we're not going to have a change. But no change in the value, but we are going to have a change in what it looks like. And this is really exciting because if we multiply this together, you know that the top is going to be 2 radical 7. And then what happens on the bottom is the important part. Radical 7 times radical 7, you know from our earlier work, is just 7, no longer a radical. And now that we no longer have a radical in the denominator, we only have one radical. It's completely simplified. There are no fractions. So we have an answer. And we have rationalized the denominator by multiplying by this form of 1. So we're finished. Now we'll look at one more example. In this last example, I just want to put together a bunch of different concepts that I've used throughout this video to show you how we could do one problem. So we have this 9 radical 3 over 24. And there are a few different ways we could approach this. I'm going to take an approach that's a little bit different to what we've been doing so far. We know that on the top of this fraction we have 9 radical 3. And we want to simplify it with the 24. So what I'm going to do is I'm going to say, okay, well, square root of 24 is the same thing as the square root of 8 times the square root of 3. And you might be saying to yourself, well, Miss Santilli, that is not really useful because the square root of 8 is not a perfect square and neither is the square root of 3. Aha, but look what happens. I can cancel out those radical 3's because they're multiplied by one another, they just cancel. So now we're at 9 over radical 8. But of course, I need to rationalize this denominator. So I used my multiplication property here, did some canceling. Now I'm going to rationalize my denominator. Here's radical 8 over radical 8. And when I do that, I get 9 radical 8 over 8. That's not bad. However, we look at this radical 8 needs to be simplified. So I'm going to go over here and I'm going to write this 9. And then that radical 8, I'm going to write that as radical 4 times radical 2. And I think you all know why. And that's because if I continue, 9 times radical 4 is really 9 times 2 times radical 2. So we could take this radical 4, make it a 2. And now that is all over 8. We want to try to simplify as much as we can. And I see that I can cancel out a 2, make that a 1. Cancel out an 8 and make that a 4. So what we're left with, really, at the end, is a 9 radical 2 over 4. And the reason I showed you this problem, which just has a lot of different things going on it all at once, is that I wanted to emphasize to you that there are many different ways to get to the right answer in these problems. So you want to use the strategies we just talked about, but you've got to be creative and think about different ways to try them. Speaking of which, it's now your turn. Here are 3 simplifying problems that I'd like you to try. Try them in your notebook. We'll start off our next class talking about them. So 1, 2, 3, try them out, and you're done. Thanks a lot. See you soon.